Hey there. Ever catch yourself staring up at the night sky and wondering, what if I could just pack my bags and move to Mars? Or, maybe pondered the wild idea of living forever. I know. Sounds straight out of science fiction, right? But here's the thing. Some seriously brilliant minds, scientists, engineers, you name it, are already working on turning these seemingly impossible dreams into reality. We're talking folks like Elon Musk, Jeff Bezos, Richard Branson. These billionaires aren't just playing around. They're investing billions into space travel, pushing the boundaries of what we thought was possible. And who knows, maybe we're not alone in this vast universe. Imagine the implications of discovering another intelligent civilization out there. It's mind-boggling. Today, we're diving deep into the fascinating possibilities for the future of humanity, especially those that take us beyond the confines of Earth. Buckle up, it's going to be a wild ride. It's funny how history sometimes plays out. Like take the early days of rocketry in the U.S. We had Robert Goddard, a brilliant American rocket scientist, making groundbreaking strides, but the government didn't exactly roll out the red carpet for him. They were skeptical, to say the least. Fast forward to after World War II, and Wernher von Braun, a German rocket scientist with let's say a complicated past linked to the Nazi regime, arrives on American soil. His expertise was too valuable to ignore, so let's just say they looked the other way. But here's the kicker. Von Braun ends up working with Walt Disney, of all people, on these animated TV specials about space. And guess what? Those shows inspired a whole generation of future rocket scientists. Talk about unintended consequences. But it was the Cold War that really lit the fuse on the space race. The rivalry between the U.S. and the USSR became this intense competition to see who could reach for the stars first. Both sides were essentially modifying V-2 rockets, the ones developed by the Germans during the war, which ironically were based on Goddard's early prototypes. It's like this weird circle of innovation. It makes you wonder if Goddard ever imagined his work would lead to a global space race fueled by superpower rivalry. Now, let's shift gears and talk about living on the moon. It's not just a distant dream anymore, it's a real possibility that scientists are actively exploring. But imagine setting up camp on the lunar surface, not just for a quick visit, but for months, years, maybe even generations. It's a logistical nightmare, right? First off, you've got the essentials. Food, water, air. You can't just order takeout or swing by the grocery store when you're living on the moon. We'd need a constant supply chain from Earth with unmanned lunar probes making regular deliveries of everything from freeze-dried meals to maybe even space pizza. But in the long run, we'd need to figure out how to live off the land, so to speak. That means figuring out how to produce oxygen and grow food right there on the moon. Scientists are already exploring ways to generate oxygen through chemical reactions using lunar resources. And with water, which we know exists on the moon, hydroponic gardens could become a lunar reality. It's fascinating to think about, isn't it? And speaking of prime real estate, the lunar poles might be the perfect spot for a base camp. Constant sunlight for solar energy and potential ice deposits make it pretty tempting. It's almost as if the moon is saying, hey, come on over and set up shop. Now, when you think about resources, you can't ignore the asteroid belt. It's like the Wild West of space, a cosmic gold rush waiting to happen. Ceres, a dwarf planet hanging out on the asteroid belt, could be our base of operations. I mean, it's absolutely massive compared to other asteroids. And NASA's Dawn mission gave us a pretty good glimpse of what it's made of. The possibilities are endless. We could be talking vast deposits of valuable minerals, metals, who knows what else. It's like a cosmic treasure chest waiting to be unlocked. And then there's Mars, the ultimate frontier, right? Terraforming Mars, turning it into a second Earth, that's the grand vision. But let's face it, it's a colossal undertaking. The first manned mission to Mars will be all about laying the groundwork, establishing a foothold. Can you picture it? That heart-stopping moment when the landing module touches down, the hatch opens, and those first brave astronauts step out onto the Martian surface. It'll be a moment etched in history, that's for sure. But Mars is not exactly a welcoming environment. We're talking lower gravity, freezing temperatures, and an atmosphere that's not exactly breathable. It's a harsh mistress, this red planet. But there are some brilliant minds working on ways to tame it. Robert Zubrin, an aerospace engineer, came up with a plan called Mars Direct, which focuses on being cost-effective and sustainable. It's all about living off the Martian land, utilizing resources that are already there. They've even got this Mars Desert Research Station in Utah, a simulated Martian environment where volunteers can experience what it might be like to live on the red planet. I've always been a bit of an armchair astronaut myself, so the idea of spending a few weeks in a Martian simulation sounds pretty awesome, to be honest. Now, before we get too fixated on Mars, let's consider some other celestial options. I'm talking about the moons of gas giants, places like Europa, a moon of Jupiter, and Titan, a moon of Saturn. These aren't just boring chunks of rock, you know? They're like mini-worlds with their own unique characteristics, oceans, atmospheres, maybe even life. Who knows what secrets they hold? The Cassini-Huygens mission gave us an incredible glimpse of Titan, revealing lakes of liquid methane and ethane. Now, methane is flammable, but Titan's atmosphere lacks oxygen, so we're not talking explosive fireballs or anything. But still, imagine the potential energy resources on a moon with lakes of hydrocarbons. It's mind-boggling, isn't it? Terraforming Titan might be a long shot, but maybe we could use comets in the Oort cloud, the outer region of our solar system, as relay stations. Think about it. Comets are basically giant, icy, rocky space travelers. They could be perfect pit stops for our interstellar adventures, providing resources and maybe even a gravitational slingshot to speed up our journeys. Now let's talk about robots. They're going to be a massive role in space exploration, that's for sure. You know how viruses replicate by hijacking cells? Well, imagine self-replicating robots doing something similar on other planets or moons. We could send a team of these robotic pioneers to a celestial body, and they could build an entire infrastructure, mining resources, constructing buildings, even repairing themselves. It's like a self-sustaining robot colony, expanding and adapting on its own. NASA actually conducted a study on this back in the 1980s, envisioning different types of robots working together autonomously, like a well-oiled machine. Of course, there are some concerns about robots becoming too intelligent, maybe even turning on us. It's a classic science fiction trope, I know, but it's a valid concern. We have to ensure that their goals align with ours, that they remain tools in our hands and don't develop aspirations of their own. It's a delicate balance, to be sure. Okay, let's shift gears again and talk about computers, specifically quantum computers. These things are absolutely mind-blowing, capable of calculations that would make our current computers look like, well, abacuses. Right now, our computers are mostly silicon-based, and they've been getting faster and faster following Moore's law, which says that computer power doubles roughly every 18 months. It's been an incredible ride, but we're starting to hit a wall. You see, there's a limit to how small we can make silicon transistors. Eventually, we'll reach a point where quantum effects start to mess things up, making our traditional computers unreliable. And that's where quantum computers come in. They harness the bizarre world of quantum mechanics to perform calculations that are simply impossible for our current computers. It's like they're playing by a whole different set of rules. Imagine simulating entire planets, designing complex molecules, cracking the toughest encryption. Quantum computers have the potential to revolutionize everything from medicine to material science to, you guessed it, space exploration. It's like opening a door to a whole new dimension of possibilities. It's both exhilarating and a little bit terrifying, you know. They could also help us design even more sophisticated robots. A quantum computer could process information at lightning speed, learn and adapt at an incredible pace. It's like having a super intelligent brain powering our robots, allowing them to solve problems and make decisions that would take us humans years, maybe even centuries, to figure out. The potential is mind-boggling. But of course, there are some major challenges to overcome. Building and controlling quantum computers is incredibly difficult. They're like delicate snowflakes, easily disrupted by the slightest disturbance. But scientists are making progress, and who knows, maybe one day we'll have quantum computers as commonplace as smartphones. Now that's a future I'm excited to see. Okay, now that we've covered robots and computers, let's talk about the big one. Interstellar travel. Getting to other stars is the ultimate dream, right? But the distances involved are just astronomical, literally. Even if we could travel at the speed of light, which is the cosmic speed limit according to Einstein, it would take years to reach even the nearest star. So how do we bridge these vast cosmic gaps? Chemical rockets, the workhorses of our current space program, just aren't going to cut it for interstellar travel. We need something radically different, something that can propel us across unimaginable distances in a reasonable amount of time. And thankfully, there's some really cool ideas out there. One of them is nanoships propelled by laser beams. Imagine a tiny spaceship the size of a postage stamp being blasted through space by a powerful laser beam from Earth. It would be incredibly efficient because the energy source is external, on the ground, not on the spaceship itself. No need to carry tons of fuel, no risk of explosions. And with our trusty self-replicating robots, we could build a network of relay stations throughout the solar system, boosting the nanoships along their journey like a cosmic relay race. Pretty neat, huh? Another idea that's been floating around is nuclear fusion rockets. These are basically giant fusion reactors strapped to a spaceship, generating immense power from the same process that fuels the stars. They could theoretically reach a significant fraction of the speed of light, but the technology is still in its infancy. We haven't even figured out how to make fusion power work reliably here on Earth, let alone in space. But hey, a few decades ago, people thought landing on the moon was impossible, so you never know. Human ingenuity has a way of surprising us. Now let's dive into some truly wild ideas, the kind that make you scratch your head and say, wait, is that even possible? I'm talking about antimatter engines and space elevators. Antimatter is like the mirror image of matter. When matter and antimatter meet, they annihilate each other, releasing an unbelievable amount of energy. It's like the ultimate power source, pure energy from the destruction of matter itself. Sounds pretty intense, right? And it is. In theory, an antimatter engine could be incredibly powerful, allowing us to travel at speeds approaching the speed of light. But there are some pretty significant roadblocks. First off, antimatter is incredibly rare and expensive to produce. We're talking trillions of dollars to produce enough antimatter to fuel a spaceship. Not exactly budget-friendly, is it? Plus, storing antimatter is incredibly dangerous. If it comes into contact with regular matter, even a tiny speck, it explodes with the force of a nuclear bomb. So while antimatter engines sound cool on paper, they're probably not going to be powering our starships anytime soon. Maybe one day, but for now, it's firmly in the realm of science fiction. Space elevators, on the other hand, feel a little more down to Earth, or rather, up to space. Imagine a giant cable stretching from the Earth's surface all the way up to a space station in orbit. You can just hop on an electric car and ride all the way up, no rockets required. It sounds crazy, I know, but the physics actually checks out. The main challenge is finding a material strong enough to support the immense weight of the cable. Carbon nanotubes, those microscopic marvels of material science, are a promising candidate, but even they aren't quite strong enough yet. But research is ongoing, and who knows, maybe one day we'll be commuting to space stations like it's no big deal. Now that's a future I can get behind. Okay, now let's get into some truly mind-bending stuff, the kind that makes you question the very fabric of reality. Warp drive and wormholes. These are staples of science fiction, but could they actually be possible? Warp drive, the stuff of Star Trek dreams, is all about warping space-time itself. Imagine creating a bubble around your spaceship that compresses space in front of you and expands space behind you. You're not actually moving faster than light, but you're effectively taking a shortcut through space-time, like folding a piece of paper to bring two distant points closer together. Pretty clever, right? A physicist named Miguel Alcubierre came up with a theoretical model for warp drive back in the 1990s, and it actually fits within the framework of Einstein's theory of general relativity. But here's the catch. It requires something called negative energy, which we've never observed in nature. It's a bit of a theoretical stumbling block, to say the least. So warp drive remains firmly in the realm of speculation, but it's not entirely impossible. Stranger things have happened, right? Wormholes are another fascinating concept. These are theoretical tunnels through space-time that could connect distant points in the universe, like cosmic shortcuts. Imagine stepping into a wormhole and instantly emerging on the other side of the galaxy. It's like a cosmic subway system, bypassing the limitations of distance and time. The problem is, wormholes are also incredibly unstable. They might collapse the moment you try to enter them, which wouldn't be a very pleasant experience. Plus, we have absolutely no idea how to create a wormhole in the first place. So while wormholes are a tantalizing idea, they're probably even further out of reach than warp drive. But hey, a dreamer can dream, right? Okay, let's shift our focus to the search for extraterrestrial life. In the past few decades, astronomers have discovered thousands of exoplanets, planets orbiting other stars. And some of these planets are located in the habitable zone, the Goldilocks region, around a star, where temperatures are just right for liquid water to exist, one of the key ingredients for life as we know it. It's exciting stuff. The Kepler Space Telescope has been a game changer in this field. It's discovered more exoplanets than any other instrument, and it's given us a much better understanding of how common planets are in the universe. And the more planets we find, the more likely it seems that we'll eventually stumble upon evidence of life beyond Earth. It's just a matter of time, or so we hope. One of the most intriguing discoveries has been Proxima Centauri b, a planet orbiting Proxima Centauri, the closest star to our Sun. It's about the same size as Earth, and it's located in the habitable zone. Now, we don't know for sure if it has liquid water or an atmosphere, but it's a tantalizing possibility, isn't it? Imagine our closest stellar neighbor harboring a planet that could potentially support life. It's enough to make your imagination run wild. Of course, finding evidence of microbial life, like bacteria or extremophiles, is one thing. Finding intelligent life, a civilization capable of building radio telescopes or launching spaceships, is a whole other ball game. But with the James Webb Space Telescope now operational and other advanced telescopes in development, we're getting closer to being able to detect the subtle fingerprints of life on other planets, even from light years away. It's pretty incredible when you think about it. And hey, maybe one day we'll even make contact with an alien civilization. It's a long shot, I know, but it's a possibility we can't rule out. And if we do make contact, it could be the most profound event in human history. It would change our understanding of our place in the universe, and it would force us to rethink everything we thought we knew about ourselves. It would be a moment of cosmic revelation, a paradigm shift for humanity. Pretty heady stuff, right? Okay, let's bring things back down to Earth, literally, and talk about extending human lifespan. I mean, who wouldn't want to live longer, healthier lives, right? It's a dream as old as humanity itself. And there are some promising avenues of research in this field that are pushing the boundaries of what we thought was possible. One approach that's been getting a lot of attention is caloric restriction. Studies have shown that animals that eat fewer calories tend to live longer. It seems counterintuitive, but it's a consistent finding across different species. The theory is that caloric restriction reduces the amount of damage that cells accumulate over time, slowing down the aging process at a fundamental level. Now, I'm not suggesting we all go on starvation diets, but it's an interesting area of research that could lead to new insights into how we age and how we might slow down the process. Another approach involves manipulating telomeres. These are the protective caps at the ends of our chromosomes that shorten as we age, like the plastic tips on shoelaces that prevent them from fraying. If we could find a way to prevent telomeres from shortening, or even lengthen them, we could potentially slow down or even reverse the aging process. It's a bold idea, but it's not entirely out of the realm of possibility. Scientists are also studying age genes, genes that seem to play a role in how long different species live. If we can figure out how to manipulate these genes, we might be able to extend human lifespan significantly. It's like tweaking the genetic code to adjust the expiration date on our cells. It's a fascinating area of research, but it's also fraught with ethical considerations. Is it right to tamper with the natural aging process? What are the societal implications of a world where people live much longer lives? These are questions we need to grapple with as we develop these technologies. It's not just about pushing the boundaries of science, it's about understanding the consequences of our actions and making sure we're using these powerful tools responsibly. Okay, let's shift gears again and talk about genetic modifications. As we learn more about the human genome, we're gaining the ability to edit genes, like using a molecular scalpel to make precise changes to our DNA. This opens up incredible possibilities, from correcting genetic defects to potentially enhancing human capabilities. Imagine a world where we could eliminate genetic diseases, boost intelligence, increase muscle mass, even enhance our senses. The possibilities are both exciting and a little bit daunting, to be honest. But there's this interesting idea called the caveman principle that suggests there's a limit to how much we want to alter ourselves. Our basic desires and motivations, the things that drive us as human beings, haven't changed much in hundreds of thousands of years. Despite all the technological advances we've made, we still crave love, connection, meaning, purpose. These are fundamental human needs, deeply rooted in our biology and our shared evolutionary history. So while we might be tempted to use genetic modifications to create superhumans, to transcend our limitations and become something more than human, we might ultimately choose to use them in more subtle ways. Maybe we'll focus on enhancing our social skills, improving our physical appearance, or boosting our resilience to disease. It's an interesting thought experiment. How far will we go with genetic modifications? Will we embrace them fully, or will we ultimately decide that some things are best left untouched? Speaking of searching for intelligent life, there's this incredible project called SETI, the Search for Extraterrestrial Intelligence. It's basically a group of dedicated scientists using radio telescopes to scan the heavens, listening for any signs of alien signals. They're hoping to catch a cosmic hello from across the vastness of space. It's a long shot, I know, like finding a needle in a cosmic haystack, but it's such a fascinating endeavor, isn't it? The sheer audacity of it, the idea that we might actually be able to detect a whisper from another civilization light years away, it's enough to give you goosebumps. But then there's this paradox, the Fermi paradox, that throws a bit of a wrench into the whole alien hunting business. It basically asks, if the universe is so incredibly vast and so incredibly old, why haven't we encountered any alien civilizations yet? I mean, statistically speaking, there should be tons of them out there, right? With billions of galaxies, each containing billions of stars, the odds of us being alone in this cosmic ocean seem pretty slim. So where is everybody? It's a question that has baffled scientists and philosophers for decades. There are a lot of possible explanations, of course. Maybe intelligent life is incredibly rare, a cosmic fluke that happened to occur here on Earth but nowhere else. Or maybe civilizations tend to self-destruct before they can reach out to the stars, succumbing to war, environmental collapse, or some other existential threat. It's a sobering thought, isn't it? The idea that we might be on a similar trajectory, hurtling toward our own demise. Or maybe, just maybe, the aliens are out there but they're choosing to stay hidden, observing us from afar, waiting for us to reach a certain level of technological or ethical maturity before revealing themselves. It's like a cosmic test, a trial by fire to see if we're worthy of joining the galactic community. Who knows? The possibilities are as vast as the universe itself. There's also this fascinating scale, the Kardashev scale, that tries to categorize civilizations based on their energy consumption. It's a way of measuring how advanced a civilization is, how much power they can harness. Type I civilizations can harness all the energy on their planet, from sunlight to wind to geothermal. Type 2 civilizations can harness all the energy of their star, maybe by building giant structures called Dyson spheres that encompass their entire sun, capturing every photon of energy it emits. And Type 3 civilizations, well, they're the real cosmic powerhouses, capable of harnessing the energy of an entire galaxy. It's mind-boggling to even contemplate the kind of technology and ingenuity required to reach that level of mastery. We humans, sadly, are still stuck at Type 0, barely scratching the surface of our planet's energy potential. We're like cosmic toddlers, fumbling around with our toys, figuring out how things work. But hey, we've got to start somewhere, right? And if we can survive long enough, if we can overcome our short-sightedness and our self-destructive tendencies, maybe, just maybe, we'll reach Type I status, and then who knows? The possibilities become truly limitless. But let's say we do become a spacefaring civilization, a species that can spread its wings and soar among the stars. What will that mean for humanity? Will we stay unified, a single species with a shared destiny, or will we diverge, evolving into separate branches of humanity, each adapted to its unique environment, its unique challenges? It's a question worth pondering, isn't it? The idea that we might one day become a multi-planetary species scattered across the galaxy, each branch evolving along its own unique path. Think about the Great Diaspora. When early humans migrated out of Africa and spread across the globe, adapting to different climates, different landscapes, different lifestyles. Over thousands of years, different populations evolved distinct physical and cultural traits. And imagine that process playing out on a cosmic scale, with colonies on different planets, different star systems, even different galaxies. It's both exhilarating and a little bit terrifying to contemplate. But maybe there's a way to bypass the limitations of physical travel, to bridge the vast distances between stars without spending centuries or millennia trapped in a spaceship. What if we could upload our consciousness, the essence of who we are, our thoughts, our memories, our experiences, into a laser beam and transmit it across the galaxy at the speed of light? It's called laser porting, and it sounds like something straight out of science fiction, I know. But some scientists believe it might actually be possible, at least in theory. Imagine creating a detailed map of your brain, all the neural connections, all the intricate pathways that make you, you. And then imagine encoding that information onto a laser beam. A beam of pure light, carrying the essence of your consciousness across the vast emptiness of space. It's like beaming your soul across the galaxy, leaving your physical body behind. On the other side, a receiver would capture the laser beam, decode the information, and reconstruct your consciousness in a new body, maybe a robotic avatar, a genetically engineered clone, or even a simulated environment. You'd essentially be teleporting your mind across the galaxy, bypassing the constraints of time and distance. It's a mind-boggling concept, isn't it? The idea that we might one day be able to travel the stars as pure consciousness, disembodied beings exploring the universe at the speed of light. Of course, there are a ton of technical challenges, not to mention the ethical and philosophical implications. What happens to the original you, the one left behind? Is the uploaded version truly you or just a copy of simulation? And what are the risks? Could someone hijack your consciousness, manipulate your thoughts, your memories, your very identity? It's a bit of a Pandora's box, this laser porting business. But it's also a tantalizing possibility, a glimpse into a future where the limitations of our physical bodies no longer define the boundaries of our exploration. But even if we figure out interstellar travel, even if we crack the code of laser porting, there's still one ultimate challenge we can't escape: the end of the universe itself. I know, it's a bit of a bummer to bring it up, but it's something we have to face sooner or later. The universe, as we know it, is not eternal. It had a beginning, and it will have an end. And the end, well, it's not going to be pretty. There are a few different scenarios for how the universe might meet its demise, each more dramatic than the last. One possibility is the big freeze, where the universe keeps expanding and cooling until everything eventually freezes solid, a cosmic ice age that engulfs all of existence. It's a slow, gradual death, a fading away into darkness and silence. Another possibility is the big crunch, the opposite of the Big Bang. In this scenario, the expansion of the universe eventually reverses, and everything collapses back in on itself. A cosmic implosion that erases all matter, all energy, all time and space. It's like a cosmic rewind button, taking us back to the singularity from whence we came. And then there's the big rip, the most dramatic and violent of all the endings. In this scenario, the expansion of the universe accelerates at an ever-increasing rate, driven by a mysterious force called dark energy. Eventually, the expansion becomes so rapid that it tears apart galaxies, stars, planets, even atoms themselves. It's a cosmic shredding, a complete annihilation of everything we know and love. Not exactly a happy ending, is it? But maybe, just maybe, there's a way out. Maybe some advanced civilizations, those hypothetical Type 3 beings with their godlike powers, will find a way to escape the dying universe, to cheat death itself. Maybe they'll create new universes, pocket dimensions where life can continue even as the old universe fades away. Or maybe they'll discover a way to tunnel into parallel universes, hopping from one reality to another as their old homes become uninhabitable. There's this intriguing idea called the anthropic principle, which suggests that the universe is fine-tuned for life, that the fundamental constants of physics are precisely balanced to allow for the emergence of stars, planets, and ultimately conscious beings like us. Maybe it's not just a coincidence, this delicate balance, this cosmic Goldilocks zone, where everything is just right for life to flourish. Maybe there's deeper purpose to it all, a grand plan that we're just beginning to glimpse. Or maybe we're just a cosmic accident, a random blip in the vastness of space and time, a fleeting spark of consciousness in an indifferent universe that doesn't care whether we live or die. Who knows? But either way, it's an incredible journey, this cosmic ride we're on. And it's up to us to make the most of it, to explore, to learn, to create, to love, to experience all that this universe has to offer while we still can. So what's the meaning of it all? Where are we headed? Are we alone in the universe? These are questions that have haunted humanity since we first looked up at the stars and wondered about our place in the grand scheme of things. And as we explore the cosmos, as we delve deeper into the mysteries of the universe, maybe, just maybe, we'll start to find some answers. Or maybe we'll just uncover more questions, deeper mysteries, more layers of cosmic complexity. But even if we don't find all the answers, even if we never solve the riddle of the universe, the search itself is what makes life so fascinating. It's the curiosity, the wonder, the insatiable desire to understand our place in the cosmic tapestry. That's what drives us to push the boundaries of knowledge, to explore the unknown, to reach for the stars, both literally and figuratively. So keep looking up at the stars, my friends. Keep asking questions. Keep wondering. Keep exploring. Because the universe is full of wonders, and who knows what amazing discoveries lie ahead. The journey is just beginning, and the possibilities are endless. It's wild to think about all the possibilities, right? Like some of the theories out there about the future of humanity are just mind-blowing. Imagine merging with advanced AI, like becoming, this super intelligent collective consciousness, a hive mind that spans the globe, maybe even the galaxy. Or picture this, evolving into a Type 5e civilization, so advanced that we can manipulate space-time itself, create new universes, maybe even escape the death of our own universe. It's enough to make your head spin. And honestly, it makes you ponder the nature of consciousness. What does it mean to be human? Will we even be recognizable as humans 1,000 years from now, 1,000,000 years from now? Will we transcend our physical bodies, our limitations, and become something entirely new, something beyond our current comprehension? If we could upload our consciousness into a computer, would that grant us a kind of immortality? Or would it just be a copy of our consciousness, a digital echo? Well, the original version, the real us, fades away. These are deep philosophical questions, and I don't claim to have the answers. But it is exciting to think about the possibilities, to imagine the potential paths that humanity might take as we venture further into the unknown. And hey, maybe one day we'll even figure out how to create our own baby universes. It sounds crazy, I know, like something out of a science fiction novel. But some physicists believe it might actually be possible, at least theoretically. Imagine creating a tiny pocket of space-time, a seed for a whole new universe, with its own laws of physics, its own unique properties, its own potential for life. It's a mind-boggling concept, the idea that we could become the architects of our own cosmic reality. It's a thought that makes my head spin. But it also fills me with a sense of awe and wonder at the sheer scale and mystery of the universe. We're just beginning to scratch the surface of what's possible, to glimpse the true potential of our existence. The universe is vast, mysterious, full of wonders that we can't even begin to imagine. And we as a species are just starting to explore, to learn, to push the boundaries of what we thought was possible. So let's keep exploring, keep pushing the boundaries of knowledge, and never lose that childlike sense of curiosity and wonder. Because who knows what amazing discoveries lie ahead? What mysteries will we unravel? What wonders will we behold? The journey is just beginning, and the possibilities are truly endless. And that's our deep dive for today. I hope you enjoyed exploring these mind-blowing possibilities for the future of humanity. Until next time, keep looking up at the stars and keep wondering.